Hi. Okay, this is month later, and as you see, I got a speech problem, but I wanted to continue this series with a low temperature switch, and so today we talk about measuring the voltage. And I have a little board here, and I would like to think about something with you guys together. Now we have a solar panel here, and the solar panel has plus and minus. Then it goes to the charge regulator, and from the charge regulator it goes to the battery, and basically that's our system. Okay, we have a load, our consumer sensor and so on, they are here, and that's it. That is what our system more or less looks like. Some fuses in between and other stuff. So if we want to measure voltage, we have to measure the voltage in reference to something. And of course we measure the voltage in reference to the negative. We measure the voltage in reference to the negative. We have chosen for our system also an N-channel IGBT, and that means it is down here in the negative line. Okay, so if we want to measure voltage, we could actually put a voltage divider here in between here. That would look like this. Here's plus, then a resistor, then another resistor, and there's ground, and here is our 0 to 5 volts. The Arduino can, on the analog input, can only understand 0 to 5 volt. My solar panels, they put out something like 100 volts. So to get 0 to 5 volts, instead of 0 to 100 volts, we need this voltage divider, and we divide this by 100, and so we have 9.5 kilo ohms here and 0.5 kilo ohms here, and we get 0 to 5 volt out here. The same we can do, of course, on this side here. All right, but yeah, there is a little problem, because if we do that, we have our IGB here and our IGB. If we have this one open and we have this both connected to ground, yeah, then we get something like a short circuit. Not really a short circuit, but it's a connection, a bridge sozusagen. This bridges to there, even that is open, and these are tiny wires. And anyway, this would all not work. So we have to forget this. This is not working. And what I find also very important is that in industry standards you shouldn't measure straight with your system. You should have that always galvanically isolated. For that reason, we need to measure galvanically isolated voltage. How can we do that? I ordered these little pieces. This is a affordable solution for this problem. This is a current, an isolated, galvanically isolated current to voltage converter. So you put a current in and you get a voltage out. Fantastic. It can't be easier. And this piece is actually only like, I think, $3. Okay, so we have this. What it does? Okay, and then explain this a little. What it actually does is it measures the current, digitizes that current in a digital signal, then it transfers that digital signal, also ones and zeros, an und aus, on and off. So it transfers that to a digital to analog converter that receives that signal via an optocoupler and converts into voltage, and that's it. So we get that separation here. And that's what we're gonna do actually. What we're gonna do is we grab that positive here, we grab that positive, we add a resistor, I call this R1, and we feed it into that isolator E to V. Okay, we feed it into that isolator and then we let it flow to negative. That's our input, and that's all. So we know that we have a range here from 0 to 20 milliamps, and that's what we need to know. So maximum is 20 milliamps. So we have to restrict our voltage. That we have 100 volts here. We need to restrict that to 20 milliamps. I decided for myself that my solar panel has 100 volts and then 20 milliamps are flowing. That's a little lot. I don't want to measure in this range. So I say that I have 20 milliamps by a voltage of 320 volts. So when my voltages are always around 90 volts, then I have a third of this current flowing, that is 786 milliamps, and that's something I can live with. That's it. So that is how we do it on the input side. And now we think about the output side. We have on the output, we have a voltage. We have 0 to 5 volt. And there are two little potentiometers. One is the zero adjustment and the other one is the range. We can set the range here, so no big deal. We don't need to calculate actually anything. What we can do is we can add a protective resistor here. Let's call this R2. And we can add here, just for fun, a Zener diode, a 5 volt Zener diode. So I do that because for two reasons. I want to protect the Arduino here on the input, that it will never get more than 5 volts. We feed in voltage, so we can actually, it's not a big deal to add a resistor here. And later we can calibrate that when all is connected. So this is the whole voltage measuring setup. There is no more to it. Okay, by 100 volt, what would be the resistance? It's very easy. I said 320 volt is 20 milliampere. That means R equals U divided by current is 320 divided by 20 milliamps is something around 15 kilo ohms. Let me see, how much is that? 16 kilo ohms. This is 16 kilo ohms. So this is the measurement of this resistor, And on the other side, okay, that's not a big deal. What kind of resistor we put in there? We have a current flowing here. I don't know, flowing here. Sorry, we have a current flowing here into the Arduino. I don't know, 0.5 milliamps or 1 milliamps. So if you put a 1K resistor there, you are probably fine. Just bigger or smaller, you can make it 500 ohms. The point is when it's getting here over 5 volts, like 7 or 8 volts, then this starts conducting, and the voltage is here and not here, and that's what we want to protect the Arduino. Okay, so that's the setup we have, and we do that twice. We have this once here on this side and this once here. And not forget, this isolator needs a power supply. That would be something between 7 and 30 volts, 7 to 30 volts. I put there 12 volts. Okay, that's in relevance to, of course, to the common ground here, and we're done. We can measure galvanically isolated this voltage and this voltage separately without connecting the grounds, have common grounds. So here we see the setup of the little current to voltage converter. We see it's powered up. There's a little red LED on there. We provide it with 12 volt. It's coming in here, ground and 12 volt. And then we feeding in over through this device here. I'm feeding in right now 6 milliamps on the current side. That correlates to 680 millivolts. This is just for I just wanted to know how many volts are this actually when I feed in 6 or 20 milliamps. And so I'm measuring the voltage. Then we have the output. That's the one here in the middle, and that's this one here. And this one shows us right now 1.5 volts. Now let me go down with the current. I click here on this little button, and let me go down to, let's say, 1 milliamp. Okay, this is 1 milliamp. That's actually 0 milliamps. And what do we get on the output? We get hardly anything. We get 200 millivolts. See if we can get even lower. Yeah, no, even lower, and this one goes to 0 as well. And on the output, we see we have 0 voltage on it. This works quite nice. I adjusted the 0 here with that potentiometer right there. So let's go up to, and now let's go up to, what am I, 3 milliamps. We get 0.7 volts. Let's go up to 10 milliamps. 10 milliamps. Actually, it's 8. So 9. We get 2.5 volts. That is pretty close. 2.4, 2.3. That corresponds to 1 volt on the input side. And on the output 2.5 volts. And now let's go to the maximum. That's 20 milliamps. 18, 19, 20. Okay, that corresponds to 5 volt. I have adjusted this with a range potentiometer here. so we get 5 volt out, and this 20 milliamp corresponds to 2 volts, just for knowledge. And that's it actually. It works very smooth and very fine. One more thing, that these 2 boards, this is called, I think it's called a shield, and this is, I don't know the English word, it's a proto board or something like that. You put your electronic components like resistors and other stuff on here, and you can connect the dots in the back, and that's actually a good way to solder if you have little components or something like that, to have them nicely connected and nicely located. This is what I use normally. I don't use those shields because for me they're a little too small. I'm old and I need it a little bit bigger, so I use this here, and I can solder wires to it. And maybe this time I use a shield, because this is an Arduino Uno shield and a half. I use an Uno for this project, and I will see. That was it. Thank you very much. Oh, maybe you were wondering why this guy is hanging here. I will talk about this guy in the next clip. The next clip is about the power supply. How do we supply our switch with power? And this is a company that makes a device that is very, very useful for that. I wish you all a nice day, and bye until the next time.